Hi everyone, I'm Kunal Sankhe and welcome to my channel Code for Wireless. In our last video, we discussed about input embedding, and in this video, we'll talk about positional encoding. So let's get started. So output of the input embedding is added with the positional encoding and summed up here and is provided as an input to multi-head attention network. So positional encoding and input embedding outputs are added together. Now, what is positional encoding? Positional encoding informs transformer about position of its individual tokens in the sentence. Now, why is it important? Because transformer processes all the tokens in parallel. It doesn't understand or it doesn't know the order of these tokens. Consider the statement, the cat sat on the mat. Now, if we replace cat with the mat, the meaning of the sentence completely changes. The mat sat on the cat doesn't make sense. It's completely different sentence. That's why the order of these words are important in a sentence, and we want to inform the same order to the transformer model. And the way to do it is through positional encoding. So in positional encoding, each of these tokens represent a embedding vector, and that embedding vector depends on the position of that token in within a sentence. Now for the same sentence, the cat sat on the mat, we have input embedding vector that we derive from the previous step. So for each of these token, we have input embedding vector, which is of size 512, and this number is presented in a paper. Attention is all you need. So for each token, we have positional encoding vector of size 512. So we sum these vectors together. So this number is added with this to get this number. Similarly, this is get added with this to get this number. So input embedding and positional encoding are added together as an encoder input. Now, one thing that we need to understand, this word the, even though it is exactly same, they have different positional encoding vector. So this vector is different from this vector, and the reason is the position of this the is different from the position of this the here. So positional encoding carries the information about the position of that token in that sentence, and that's why it's important to understand the difference between input embedding and positional encoding. Now let's try to understand how these positional encoding vectors are derived. Now in the paper, attention is all you need, authors has provided an intelligent way to derive these vectors. So they have used sine and cosine waves. Now why sine and cosine are used? First, they are periodic in nature and they provide a guarantee that the small changes in the input will produce an output which are closer to each other. So what does that mean? The word the and the cat, they are closer in the sentence, and that's why their encoding vector will be closer to each other in high dimensional space. On the other hand, this the and the mat are far from each other, and that's why their encoding vector will be away from each other in the high dimensional space. So the sentence, if it is a longer, the first word and the last word will be far from each other in the high dimensional space. Now these are the formula that the authors have used. So let's try to understand this. So P stands for positional encoding. We have a position and we have index. So this is position. So what does position means? Position means position of the token in that sentence. So let's say this is the first token. So the index starts from 0, 1, 2, 3, 4, 5, and 6. So this is the position, and the index means in this vector, this is 0 index, this is 1 index, second index, and this is 511 because this is the size of 512. Now, so here the position is 0 and the index is 0. Now we have sine and cosine. So sines are used for even index. So this is for even and this is used for odd. So for this position we will use sine, and for this odd position we will use cosine. So again this is sine and so on. So we will use sine and cosine in that order. Um, One thing that we need to understand is this parameter here for cosine, even though the index is 1, we use 2i. So here 2i plus 1 is 1. So that's why here I is actually 0, right? So here for this position we will use 2i equal to 0. Other thing that we need to understand is this word the and the, it has the exact same input embedding vector, but they don't have the same positional encoding vector, because the position of this the is here, it is 0 and it is at 4. So they will have a different positional encoding vector because this value is different from this. So it changes the p value here. Okay, so that's all for positional encoding. So as we discussed earlier, the input embedding output is added with positional encoding vector, and this addition is then fed to input as multi-head attention network. Now, before learning about multi-head attention, we will first talk about self-attention, and that we will do in our next video. So thanks for watching. Subscribe my channel Code for Wireless, where we will learn more about LLM and how to program this LLM from scratch. Thank you.